Welcome to 3D Print Pulse, your essential weekly update from the cutting edge of 3D printing and additive manufacturing. Every week, we bring you the most important news and developments. The episodes are crafted by All3DP's expert editors and voiced by text-to-speech so that we can go hunting for news again. Ready for the latest? Let's dive right in.
Getting a custom-fit 3D printed prosthetic arm or leg in the US is about to become far more accessible. In a landmark move, Medicare, the federal health program for older Americans and those with disabilities, has officially approved reimbursement for these custom-made devices. The move by the Durable Medical Equipment Medicare Administrative Contractors and the Pricing Data Analysis and Coding officially designates additive manufacturing as an acceptable fabrication technique for prosthetics. Historically, the lack of clear reimbursement codes has been a major barrier, preventing widespread adoption of the technology in hospitals and clinics. This decision effectively removes that financial uncertainty. According to Francois Minek, VP at HP Additive Manufacturing Solutions, the decision changes everything. It means clinicians can now confidently prescribe 3D printed prosthetics, insurers can cover them, and patients, especially the elderly and those with disabilities, will gain access to care that is faster, more affordable, and highly personalized to their unique needs. This achievement builds on a previous milestone in 2024, when 3D printing was approved for orthotic device reimbursement. This success was largely driven by a consortium led by HP, which focused on generating the clinical evidence needed to support reimbursement and integrate digital manufacturing into clinical workflows. This ruling is poised to accelerate the growth of industrial 3D printing systems in the healthcare market and transform patient care across the United States.
A new study is providing concrete data on the health risks of desktop 3D printer emissions, moving the discussion from laboratory testing to a real-world classroom environment. The 18-month investigation was conducted by the Chemical Insights Research Institute, part of UL Research Institutes, along with Georgia State University. The team monitored air quality in a classroom, actively using FDM printers with PLA-based filaments. The researchers found that emissions of ultrafine particles, or UFPs, were 5 times higher than typical background levels while the printers were operating. These microscopic particles are a major health concern, as they can be inhaled deeply into the lungs. The study also confirmed that emissions of volatile organic compounds, VOCs, vary dramatically based not on the base plastic, but on the specific filament additives. This means that a filament's color or special properties significantly impact its emission levels. Most critically, the study challenges the common assumption that PLA is inherently safe simply because it is a bioplastic. Researchers identified that some PLA filaments released known hazardous air pollutants and irritants, including formaldehyde and acetaldehyde. This data provides new evidence for a long-standing safety concern in desktop 3D printing, especially in poorly ventilated spaces like schools, homes, or offices. The primary conclusion of the study is a clear call for a specific safety tool, the printer enclosure. The researchers strongly recommend that all desktop 3D printers be operated inside an enclosure, one that is specifically equipped with air filtration systems like HEPA and activated carbon filters to mitigate exposure. You can read more on 3D printer emissions and how to avoid them on all3dp.com.
FDM desktop 3D printing has long been defined by a fundamental limitation: the 3-axis X, Y, Z gantry. This layer-by-layer approach creates parts that are inherently weak along their Z-axis and often require wasteful, complex support structures. Now, a new partnership between 2 London-based companies, Generative Machine and AI Build, is poised to challenge that convention by bringing industrial 5-axis capabilities to the desktop. The new machine is the Generation 1 5-axis printer. Its practical impact is a change in how parts are fabricated. Instead of just printing flat slices, the Generation 1 can rotate and tilt the print head, allowing it to print non-conformally. This means it can follow the contours of a curved surface, aligning layer lines for maximum part strength and drastically reducing, or even eliminating, the need for supports. The hardware itself is an evolution of an open-source project. Its unique, fluidly organic frame is not traditionally manufactured. It is generatively designed and then 3D printed from metal powder aluminum, creating a lightweight yet rigid structure. Second, the machine is powered by A-Build's sophisticated software. This is a major development, as A-Build's platform is typically used to control enormous, industrial KUKA robotic arms for large-format manufacturing. This collaboration scales that powerful, non-planar slicing engine down to a desktop form factor for the first time. The machine features a modest build volume of 140 by 180 millimeters and is focused on printing standard materials like PLA and PETG, but with complete geometric freedom. A limited batch of the Generation 1 will be available for pre-order at the upcoming Formnext, with pricing expected to be in the professional desktop range. And now a word from our sponsor.
Are you an engineer or designer looking for high-precision CNC parts? Tired of waiting for manual quotes? Stop waiting. Craftcloud is your solution for instant on-demand CNC machining. Upload your CAD file, select from a wide range of materials, and instantly compare real-time quotes worldwide. Get the best price on precision parts, from rapid prototypes to mass production. We offer 3-axis and 5-axis milling, turning, and more. No minimum orders, just transparent pricing, fast delivery, and expert service. Craftcloud. We turn your CNC ideas into reality.
Let's finish with news bulletins. A significant software update from Bambu Lab, version 2.3.0, is set to unlock the full multicolor potential of its entry-level A-series printers. The update allows A1 and A1 mini users to connect to the professional-grade, multi-AMS systems for the first time. This enables 16-color printing on their entry-level machines, blurring the line between their hobbyist and prosumer ecosystems. Autodesk's Tinkercad is evolving beyond with the introduction of a new Revolve function. This tool, part of a new Sketch workspace, allows users to draw a 2D profile and rotate it around an axis to create complex, lathed 3D models. This is a significant capability upgrade for the popular entry-level CAD software, enabling the easy creation of shapes like rings, vases, and wheels. Accessory maker BQ has released a seasonal, pumpkin orange build plate for Bambu Lab printers. The product is an aesthetic variation of its existing CryoGrip Pro plate and is compatible with the A1, P1, and X1 series. A large-scale 3D printed structure called the Desert Ark has been completed in the deserts of Inner Mongolia, China. The 800-square-meter building, which will serve as a cultural tourism center, was constructed using sand-based 3D printing technology. Its organic, flowing design is intended to blend into the landscape, demonstrating a novel application for architectural additive manufacturing in remote environments.
That's it from the weekly roundup from the world of 3D printing. As usual, you can find all the links in the show notes. Thank you to our sponsor Craftcloud, and remember, you can always find more in-depth articles, reviews and guides at all3dp.com. Don't forget to subscribe and leave us a rating or review. It really helps us to bring these updates to even more 3D printing enthusiasts like you. Join us next week for another rapid-fire update. Until then, happy printing!